We all want high-performing data loading and processing. And now, as accelerators keep getting faster and faster, data loading is no longer the simple task of merely looping through your dataset. Because if the accelerators aren't getting the data at an appropriate rate, they just sit around waiting. And the last thing we want is to waste compute cycles while we wait for training data to be delivered. In a previous video, I talked about Grain, a Python library designed for reading and processing dataset for machine learning training fast. If you're not already familiar with Grain, I definitely recommend checking out that video first. We've linked it in the description down below, or you can click it right here on screen. I'll just be waiting here while you go check that out. Okay, welcome back. You've caught up on all the good stuff about Grain and the high-level DataLoader API. So now we're going to talk about the Dataset API. Dataset utilizes a chaining syntax for defining data transformation steps. It provides more general types of processing, including dataset mixing, and gives greater control over execution, like the order of data sharding and data shuffling. Earlier, we saw that sharding and shuffling were combined together in the sampler. A notable feature is its ability to preserve random access capabilities, even after performing some transformations. So you can use it to debug elements at specific positions without processing the entire dataset, which is pretty neat. Let's take a look at dataset in more detail now. Most pipelines will start with a map dataset, which gives us efficient random access to the data. The kinds of data sources allowed here are the same as what we saw earlier with DataLoader. Everything from Parquet to TensorFlow datasets to ArrayRecords will work just fine. After the dataset is loaded, you can, basically do whatever you want. A typical order of operations looks something like this. You'll do any mapping and shuffling operations, followed by filtering, and finally batching up your data for delivery to your model. One important piece to note, you need to convert the dataset to what's called an iter dataset if you want to use batch after filtering. This turns the dataset into an iterable rather than a random access dataset. Let's walk through this working example. I've loaded up a bunch of news headlines with TensorFlow datasets. First, we'll give it a shuffle and pull out the titles of all the articles. Next, we'll search through these titles for news articles about pandas and convert it to a dataset iterator so that we can set that batch size to output the dataset. It turns out, in the entire dataset, there were only a couple of articles about pandas, and most of them are about Wi-Fi. I guess that's just what it takes for pandas to make the news these days. One final note before we wrap up datasets. Once the iter dataset we were working with starts getting consumed, that iterator is called a dataset iterator. We can save that iterator's state by calling getState on it, and use that result to return to that position later using setState. This allows for quick and easy checkpointing. However, this doesn't save it to a file, just another variable. So what should we do in that case? Well, that's a perfect transition into our next topic. That's right, more checkpointing. I know it feels like we literally just talked about it, because we did, but there is slightly more to the story here. In addition to using getState on a dataset iterator, Grain also has compatibility with Orbax. What's Orbax, you ask? Orbax is a library dedicated to checkpointing and exporting your models. Using Orbax, you can checkpoint the input pipeline along with the model all together if you wish, and it handles distributed training use cases really well. When we use Grain together with Orbax, we'll use the grain.checkpoint.checkpointSave function, which takes the dataset iterator directly as its input. No modifications needed. The Orbax checkpoint manager asynchronously saves it all to a file so that you can freely then resume training as needed on other worker machines. By combining the Grain Dataset API, checkpointing, and Orbax, you have a full end-to-end solution for data loading along with asynchronous checkpointing of your loading progress. That means you can move on to tackling your training code. Now that you've got data loading figured out, you're going to need some models, right? If you want to learn more about loading model checkpoints from Hugging Face Hub, check out this video about how to use Keras Hub for loading checkpoints into Keras with your choice of any backend. So what kind of challenges do you face in machine learning and data loading? Share your thoughts in the comments below. I'll try to answer any pressing questions in a future video. And if you enjoyed this particular video, let me know by clicking that like button. That's all for now. I'll catch you in the next one.